In this video, we are going to look at how vectors can be added together. Hi, this is Sean Huang from the Physics Department. If you have not watched the video on vectors and vector addition, you can find a link down below in the description. In the following, that video will be referred to as the previous video. In problem number 36 of chapter 1, we are given the two components ax and ay of the vector A, and we're supposed to find the angle theta of the vector. From the previous video, we know that when the components are given, the magnitude will be obtained using the Pythagorean theorem, and the direction will be determined using the arctangent function. Therefore, in part C, since ax is equal to 12 and ay is equal to 17, the magnitude will be equal to the square root of 12 squared plus 17 squared. And the angle will be equal to the arctangent of 17 divided by 12. Now, it will always be a good idea to sketch a vector. So let's try that. The vector A in its component form is 12 x hat plus 17 y hat. If we look at the first term, it has a magnitude and it has a direction. By definition, that is a vector. The same is true for the second component. So a vector in its component form is actually a vector sum. We call the head-to-tail method, where we will move a vector so that the head of one meets the tail of the other. So we will move the second or the y component so that the head of x meets the tail of y. If we draw a line from the beginning to the end, we will have the vector sum, which is the hypotenuse of the triangle that you see here. From the right triangle, it is obvious that the magnitude of the vector A is the square root of 12 squared plus 17 squared, and the direction of the vector is given by the angle theta, which is equal to the arctangent of 17 divided by 12. In problem number 43 of chapter 1, we have three vectors as shown in the diagram, and we need to find the sum of these vectors. First, we will need to find the component form for each of the three vectors. Let's first look at the vector A. As we said in the previous video, the x component of a vector is the projection of the vector on the x-axis. Since the vector A is in the second quadrant, the projection falls on the negative x-axis and therefore has a negative sign. If you draw this auxiliary line, then you can see a right triangle. The side, which is adjacent to the angle theta, will give you the magnitude of ax. Therefore, ax is equal to the negative of a cosine theta, where theta is 20 degrees. The projection of the vector A on the y-axis is the same as the side, which is opposite to the angle theta, and it falls on the positive y-axis. Therefore, ay is equal to a sine theta. The other two vectors are more straightforward. After obtaining the component forms of the vectors, we will line them up and add them together. The result would again be a vector in its component form. If we apply the head-to-tail method, we can see that the vector lies in the second quadrant, has a magnitude of 2.999, and a direction which is 42.86 degrees above the negative x-axis. The examples shown in this video require all the basic techniques in vectors and vector addition. In the future, you will see many problems that involve vectors and vector addition. They all can be solved the same way.